Every app claims it has AI. Your phone has AI. Your toaster probably has AI. Even your banana peeler might at this point. But how did we get here? How did we go from computers can barely add to AI writes your essays and debates consciousness? The history of AI is wild and surprisingly short. Let's walk through it. The beginning, when computers were people, 1940s. Before silicon chips, computer was a job title. Humans sat at desks calculating all day. In 1943, Warren and Walter designed the first artificial neurons. Just equations on paper. They showed you could theoretically build thinking machines. Then came Alan Turing. In 1950, he asked, "Can machines think?" He proposed the Turing test. If you can't tell a machine from a human in conversation, it passes. For in 1950, this was bonkers thinking. Computers couldn't do basic algebra, and he's talking about philosophical conversations with machines. Birth of a field, 1956. Researchers gathered at Dartmouth College for a summer workshop. John, Marvin, Claude, and Nathan organized it. John coined artificial intelligence that year. Before this, there was no name for what they were doing. Suddenly, it was a field. The workshop proposal stated they believed every aspect of learning can be so precisely described that a machine can simulate it. Bold claim. They had zero proof, but they had vision. Frank built the perceptron in 1958, the first neural network that could actually learn. It distinguished between cards marked left versus right. Frank called it the first machine capable of having an original idea. Early excitement was massive. Researchers promised human-level AI within 20 years. The government threw millions at it. They were very wrong. The first AI winter, 1970s. Reality hit hard. Making intelligent machines is really difficult. In 1973, the British government evaluated AI research. Conclusion? AI utterly failed to achieve its objectives. Brutal, accurate. The problem was a thing called combinatorial explosion. Early AI solved toy problems. Real-world complexity, it ground to a halt. Imagine teaching a computer chess by considering every possible move. Sounds reasonable until you realize there are more possible chess games than atoms in the universe. Good luck with that. By 1974, funding dried up. The government cut deep. The UK stopped entirely. From 1974 to 1980, the AI winter arrived. Progress slowed dramatically. Researchers left, universities canceled programs. Expert systems and another winter, 1980s to 1990s. Then came expert systems, programs that mimicked expert decision-making using if-then rules. The first commercial one, XCON, was built in 1980. It configured computer systems automatically and saved the company $40 million over 6 years. Suddenly, AI was back. Corporations spent over $1 billion by 1985. Japan launched a major initiative. The US did too. Specialized AI computers sold like crazy. The field was booming. Then reality hit again. Expert systems couldn't handle anything outside their narrow scope. They failed on unusual inputs. They couldn't learn or adapt. Maintaining them meant constantly updating thousands of rules by hand. Exhausting, expensive. By 1987, the market collapsed. Japan's project ended in 1992, failing to meet goals. Funding slashed again. The second AI winter arrived, longer and colder. From late 1980s through mid-1990s, artificial intelligence became a dirty word. Researchers stopped using it in grant applications because it meant rejection. The Quiet Revolution, 1980s to 2000s. While expert systems failed publicly, something important happened quietly. Jeffrey, Jan, and Joshua kept working on neural networks, systems inspired by brains. In 1986, Jeffrey and others figured out how to train them better. Most people ignored them. Other researchers said it wouldn't work. But these three kept pushing. The problem was computing power. Training these systems took massive resources. The hardware didn't exist. Progress was slow. Through the 1990s and early 2000s, they showed promise on small problems but couldn't scale. The breakthrough, 2012. Then came 2012. Everything changed. Jeffrey and his students Alex and Ilya entered ImageNet, an annual competition identifying objects in images. They built a system trained on 2 graphics cards in Alex's bedroom. His bedroom, at his parents' house. It crushed the competition. 15.3% error rate. Second place, 26.2%. They didn't just win, they obliterated everyone by nearly 11 points. At a conference, researcher Yan called it a turning point in the history of computer vision. 3 things made it work. First, 14 million labeled images to train on. Previous datasets were tiny. Second, graphics cards built for video games turned out perfect for this. They could do thousands of calculations simultaneously. Third, better techniques made training at scale possible. After 2012, everyone jumped on it. Google hired Jeffrey's team. Facebook, Microsoft, Amazon, every tech company started AI labs. Universities scrambled to hire researchers. The AI winter ended. Summer arrived hard. Language gets smart. 2017 to 2020. Neural networks conquered images. Language remained difficult. In 2017, Google researchers introduced the transformer architecture. It could process entire sentences at once instead of word by word. OpenAI built on this with GPT in 2018. It could generate human-like text, sort of. Then bigger versions. Billions of parameters, trained on massive internet text. The latest could write essays, answer questions, generate code, translate languages, and hold conversations. Not perfect, but shockingly capable. The academic and tech worlds went wild. This was fundamentally different. ChatGPT and explosion, 2022 to present. November 30, 2022. OpenAI released ChatGPT publicly. Within 2 months, 100 million users. Fastest app ever. Instagram took 2.5 years. ChatGPT did it in 2 months. Why? It worked. You could have real conversations. It helped with homework, wrote code, drafted emails. Every tech company scrambled to catch up. Google released its version. Microsoft integrated AI into search. Meta released one. So did everyone else. Companies poured hundreds of billions into infrastructure. The spending never stopped. Where we are. Jeffrey won the Nobel Prize in 2024 for his work on neural networks. Then he left Google to speak freely about AI risks. We went from "can machines think?" to AI that generates images from text, writes code, translates in real time, composes music, assists doctors, and drives cars. But serious questions loom. AI spreads misinformation at scale. It automates jobs away. Privacy concerns. Researchers worry about advanced AI risks. The entire history spans 82 years. Most progress happened in the last 12. 2 AI winters nearly killed the field. Then researchers who kept working on neural networks were proven right. Progress isn't linear. Long stretches of nothing, then sudden breakthroughs when the right algorithms meet the right hardware and data. Where next? Nobody knows. Some think we plateau. Others believe true AI is coming. The history is wild optimism, crushing disappointment, quiet persistence, and sudden breakthrough. We're living in the most explosive chapter yet.